presentation. Okay, so if you guys look at please, chapter 11. Adam chapter 11 says, putting calculation to use in a sample lighting project. That's our chapter. And it will tell you guys, the summary of this chapter is two things. Vertical calculation as well as horizontal calculation. And if you guys look at in page 97, in page 97 of the book, it will tell you guys, again, the lighting book, we're looking at the lighting book, it will tell you when you lay out your lights, if you have a major equipment in this room, Matt, and you lay out your light based on visual, the way we did it, and all of a sudden you find this lighting fixture right at the top of a big air handling unit, so you might and you will readjust these lights and relocate them strategically so it can give you the best performance of the light. So look at this, guys. This room is empty. There is no big equipment in it. Suppose I put a generator right here, right? Or an air handling unit. And the air handling unit goes all the way up to just 2 feet below the ceiling. Do I want to have a light at the top of the air handling unit, which there is nothing there to see, or so I might have to move that fixture to the left, to the right, front or back, situated away from the top of the equipment. That's what it talks about. When you lay out your fixture, first you lay them out as general lighting, right? Then you might have to go back and say, okay, well, where do I need more lights? In this area, so you can move these fixture or add more fixture to certain areas. And that's what they're doing in page 97. In the, they call it control room. Okay, do me a favor. We're going to do calculation, guys, about the vertical foot candle. So Adam, I have a switch gear. You're looking at a switch gear here. And the code requires you guys to have a lighting fixture in the electrical room. So the lighting fixture is shining at the face of this switch gear. And they're giving me the distance, getting this 4.5, 5.1, and 6.0, the distance between the lighting fixture and 0.1, 0.2, and 0.3. And they're also giving us the angle between the vertical and the light, and the distribution of the light on the face of that switch gear. Can you guys see it? 60, 50, and 40. Everybody can see what we have? The face of that switch gear. And we are to do calculation, guys, to find the foot candle on the face of this switch gear. Shall we go ahead and do it? Everybody got that? The formula that you need to use, Brian, my friend, is candela power multiplied by sine Q or theta, which is the sign that the light will make with the vertical, divided by the distance squared. You guys have done this with your friend chat. So let's go ahead and do that one. At 0.1, everybody understand what we're trying to do? We're trying to do calculation 0.1, 0.2, 0.3, coming from this fixture D. They're giving me the distance between D and 0.1, 0.2, 0.3, as well as the angles. So you don't really have to do a whole lot. Okay, now, the most important thing is so the first calculation, 0.1. Everybody can see what 0.1 is? D is 4.5. The angle right here is 60. So do me a favor, take that 60 degree, take the 60 degree, and 60 degree, take it to Fig 11.3, page 65, will you please? So 11.3, page 65, page 65, everybody. And can you guys find me the candela power from there? Page 65, 11.3, page. I think the page is screwed up here. Page. Oh, this one is not a page. So it's gonna go to at 60 degree. Page, no, it's actually page 94. I'm sorry. Page 94. Page 94 for 60. Can you guys find the candela power? I don't have 60. I have 55 or 65. Which one are you guys going to use? 65. So because there's, can you guys see where the page 90, 11.3? Everybody got that one? So I'm going to go, because I don't have 60, go to the closest. And what's the candela power? Anybody can find it? Candela power for 65. Derek, can you see where we are? We're page 94, fig 11.3, and if, yep, and you're looking at the schedule in upper left corner. So 335. Good. So this value is 335. Candela power. Any comments, guys, to find this one? Why? This is for angle 60. I went to the closest, which is 65 degree. So you go to the closest, which is 65 degree, give you 335. Because we don't want to do interpolation. Then, Karen, you drop him in here. So you have 335 multiplied by cosine. Oops, not cosine, sine. Multiplied by sine 60 and divided by the distance. The distance, guys, for the 60 degree is 4.5 raised to the power squared. When you do the math on this one, if you guys did it, you're going to end up with 14.3. So the math is 14.3. Any comments, guys? Any questions? That's 14.3 foot candle at the face of this switchgear. 14.3 foot candle. Very easy, very simple. Adam, does it make sense? Foot candle calculation. You find the distance, find the angle. Okay, now that's at point 1. Let's go do the same thing, guys, at point 2. At point 2, my friends, we need to find the candela power. Now at point 2, what's the angle? The angle at point 2 is 50. So for where am I going to do it? So for point 2, Q equal. Oops, not. So to find the candela power, so Q equal 50, right, at point 2. Take this one, guys, to the same table, fig 11.3. And what do you come up with there for 50? 696. Thank you. 696 candela power. Lumen. And then you plug it in. 696 multiplied by sine. This angle is 50 degree, guys. Sine 50 divided by the distance. The distance for the 50 atom is 5.1. Is 5.1 raised to the power squared, or power 2. And that will give me 20.5 candela power at point 2. Any comments, guys? Any questions? Does it make sense? The candela power at point 2 is 20.5. At point 1 is 14.3. So can you guys predict point 3? Now we're going to find. So what I'm doing is I'm finding the calculation at point 1, point 2, point 3, guys. Point 1, point 2, point 3. And then I need to find the maximum, minimum, and average. Right at the face of this switchgear. Any comments, guys? Any questions about that? Comments, questions? So if I ask you to find the calculation at any point here, guys, all what you need to do, Matt, to find the calculation, find the angle that this fixture is making with the face, with the vertical, between the vertical and the face of the switchgear, right? And then find the distance between the fixture and that point at the switchgear. Any comments, guys, about point 1 and point 2, please? Okay, shall we go to point 3? Okay, now for point 3, gentlemen, for point 3, the angle is 40. Can you guys see it? So for 40, let's go Q equal 40. Derek, do me a favor, will you? Fig 11.3. What do you get from fig 11.3, Derek? 842. 842 lumen. Okay. Plug them in. So you put your 842 multiplied by sine 40 and divide everything by the distance. The distance at angle 40, guys, is given as 6 feet. Square it, and that will get you a healthy, or if we're going to go right here, that will get you a healthy, if you do the math, that'll get you a healthy 15 foot candle. 15 foot candle. Any comments, guys? Any questions? Any comments? Any questions? So really straightforward, no gimmicks for that one. Straightforward. Any comments? Any questions? Brian, makes sense? Okay, so now we have 3 points, gentlemen. We have 3 points. We have, and ladies, we have point 1 is at 14.3, point 2, 20.5, and point 3, 15. The question would be, guys, and that would be the test too. The question would be, find the maximum foot candle on the face of the switch gear based on these 3 points. Okay, what's the maximum out of these 3 points? Very clearly, the maximum point is 20.5, right? That's my maximum. Find the maximum foot candle at the face of this switch gear, the largest number. Find the minimum foot candle. The minimum foot candle, guys, 14.3 foot candle. Find the average foot candle. How do you do the average if you have 3 values? Thank you. Add, divide by the number. So that will be 14.3 plus 20.5 plus 15. Divide everything by 3. And if you guys did that one, 16.5 is your average foot candle at the face of the switch gear. Very simple, very easy. One more time to summarize, guys. When you do foot candle calculation on a vertical surface, you need to take the candela power multiplied by the sine angle, the sine of the angle, divided by the distance squared. The distance square, or the square of the distance. We have a switch gear. We found 3 points at the face of this switch gear. Then we picked the largest, the maximum, the minimum, and the average. If I ask you in the test, Matt, to find the maximum to minimum ratio, what would you do? You take the 20.5 divided by what? 14.3. If I ask you, Karen, to find the average to minimum, the maximum to average, you take the maximum divided by the average ratio. Okay, guys, so that if I give you in the test, find the ratios, you take these quantities and divide them based on average to minimum, maximum to minimum, average to minimum. So that's what lighting is all about. Finding the average first and finding the ratio, guys, between these quantities. And Brian, the ratio will get you that distribution of these lights in this area. How good of your lighting distribution you have in this area. Any comments about this example before I move to next example? Any comments? Any questions? Everybody's good? Are you guys think of the turkey like I am? Turkey Day? All right. Let's do another example, guys. That's not enough. You're going to see it's very simple, very easy. Okay, here's another example. Matt. This example is the same, basically the same thing, except I would like you to find it at point. We need to find it at a point. We don't know what the distance is. So look at this. We don't know what the distance is. And we need to find this one at an angle of, where am I? I'm taking the distance. Okay, right here. Square of it. Okay. So I would like to do the calculation, guys, if at this point, oops, let's do that. At this point here, and my triangle, this is my triangle, right angle triangle. You can see that? I don't have the D. I don't have the distance. I know the distance between the face of this object and the light is 10. Can you guys see that? It's 10. This is 10. The height of the object is 8. This point is sitting at 6. So this little piece here is what? 2. Everybody understand that one? On the test, guys, I will give you a problem like this. I say, find me the foot candle at this point. And I'll give you the dimension. And you are to create a right angle triangle, right? So for example, this is very clear. From here to here is 10. Then this is from here to here is 10. This is from here to here is 6. And the top all the way 8. So 8 minus 6 give you a 2. The question would be, gentlemen, is find the foot candle at this point, right here. Gentlemen, any comments right at this point? Find the foot candle at this point using Fig 11.3. So what would you do, Derek? Find the distance. Find the distance, yep, and then find the angle. I have no idea what the angle and what the distance are. And then from the angle, and fig 11.3, I can find the candela power, plug it into the formula. Okay? So this will be example number 2. Number 2. And the question will be find foot candle at point number 1. At point number 1. Okay? Any comments, guys? Any questions about this? Where's point number 1? Is right in here. That's my point number 1. Right in here. My point number 1. Okay. Let's go ahead and do it. So let's, the first thing we need to do, guys, the first step that you need to do is find D. Okay, so let's go ahead and find my D. D, the distance equal, can you guys see the distance here from the fixture to the point equal 2 squared, right, plus 10 squared. Pythagorean theory, the hypotenuse equal the square root of the square of the two, the sum of the square of the two sides. When you guys do your math on this, you're going to find that this is actually equal 10.2 feet. That's the D. That's the first step that you need to do. Find the distance. Any comments, guys? Any questions about finding the distance? Comments, questions about finding the distance? Why do we care about finding the distance? Because I need to plug it into the formula that says candela power sine Q over distance. Okay, the next thing that we need to do after we find the distance, anybody? The Q, the angle. Okay, here's the Q. So do you guys remember from the Pythagorean theory, we can say Q equal tan inverse. The tan is always what? The opposite over the adjacent. So the opposite, what's the opposite? 10 over the adjacent to, let's try it here. Tan Q, and then we find tan inverse. So tan Q equal opposite over adjacent 10 over 2, which is 5, right? That's a 10 over 2. That will give me my 5. Then, next step, guys, is to find tan inverse. Tan inverse 5 equal, from your calculator, Adam, tan inverse 5 should be 79 degrees. 79 degrees. Okay, first find the tan. Tan is opposite over the adjacent. Sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Remember these relationships? All what you need is a tan. Opposite over adjacent. So I found the tan. 10 over 2 equals 5. Tan inverse 5 equals 79. Now I know what the angle is. Okay, now from the angle, my friends, now you take that 79 degree angle, take it to fig 11.3, and from there, 79, 75. So where are you going to go? You have the option of going to 70. From 79, Derek, you can either go to 75 or to 85. I told you guys to go to the closest. In real life, what do you do? What do you guys do in the real life? You do interpolation. Okay, so I'm going to go to the closest, which is 75 degree. What would that give me, Adam? Anybody can help Adam? At 75? 206. Okay, so that will give me a 206 foot candle. Why did I go to 75, not to 85? Which one is the closest? You go to the closest. That's just approximation, guys. If you wanted to do it, the real, find the exact number, you have to do interpolation. Okay, so we got that one. Then the rest is, gentlemen, is history. And the rest is, now I know my angle. Then foot candle equal candela power times sine, not cosine, Chad, times sine Q divided by distance squared. Plug your number in. Candela power is 206. Sine, the angle is 79. divided by the distance, Adam, we found it to be 10.2 raised to the power 2. And gentlemen, if you do the math, this should get you a healthy, wealthy number 2. A healthy, wealthy number 2. 2-foot candle. That's what I give you on the test, guys. I give you a situation like this where you have to find the distance and you have to find the angle and then plug them into the formula. Would that be hard? Yes, no, vertical. We did vertical before. It's not nothing new. So that's what this test is all about, what this chapter is all about. Finding the candela power. Then Derek talks a little bit about the zone cavity method. We use the zone cavity method, guys. That's the only thing I would like you guys to focus on this chapter. Any comments, any questions? 2 examples good? Any comments before I move to chapter 11? Chapter 12. Karen, we're good for vertical. So I'll give you an example like this, guys, and find me 3 points on the face of a switch gear or a face. Always pay attention to the distance, the angle, and the formula is there for you. Okay. Now do me a favor, guys. Can you get wow. Can you guys go to chapter 12, please? If you look at chapter 12, it says computer aided lighting design. That's exactly what we did, Karen. So all that mess that we did by hand, and at the end, you don't want to do that by hand anymore, guys. Nobody does it. So it talks about how to use a computer aided software to do all this calculation for you. That's chapter 12. Now, Derek, if you go all the way to chapter 16, and that's why I lumped them together, it says making lighting drawing step by step. Can you guys see that? Chapter 16 says making lighting drawing step by step. So I lumped something because they're related. And I'm going to review what we did, guys, with you. You guys have done it with me, done it inside and outside. That's what this chapter is. So in reality, Adam, we would not do it by hand calculation. We will do it by software. Here's what you're going to do. Number 1, you got to purchase yourself a software or get one of these commercially available softwares. We have Visual is the cheapest. When you guys go in the field, you have used it, right? It's free. AGI, anybody heard of AGI? AGI is what most of engineering firms use, guys. AGI take the lighting calculation to the next level. So if you have a hospital, and you need to do a special lighting in these and different heights of ceilings and detailed lighting calculation, you take it to the next level with AGI. Can I have thumbs up, Chad? We know that AGI will take it to the next level. So Visual, guys, will get you up to, I would say, 70%, 80% of all the lighting system that you need. Take it to the next level, you need AGI. AGI, like Visual, guys, exactly the same step that we did with Visual, we do them with AGI. Okay, now, lighting drawing step by step. When you do lighting, when we design lighting system, and this is, I hope, review for all of you guys. The first thing we need to do, inside or outside lights. You have to decide in the system, are you doing inside lights or outside light in the software? Remember, guys, how we picked inside or outside because it's default. Pick inside, outside. Then, Adam, you're going to import DWG files. Is that what you guys did me? We imported the layout of the project from CAD into Visual. In the inside or the outside, right? I hope these are review for you guys because we already done that. Import the DWG file into the software. Then, build 3D model. And what you do is we build the box, right? Box around it. If it's outdoor, the building box. If it's indoor, all the rooms that we did. When we build the box, then find IES files for the luminaires. We went, guys, and based on the specification that Chad gave you for this project, we found the type of the fixture and the IES file in the fixture schedule, So Now we find our fixtures, right? You have, this is probably, Adam, this is the most consuming time probably for trying to figure, especially for beginners like you, trying to find what the IES file for the fixture that you need. Then place the luminaires in the model, right? So you go put it, guys, surface mounted, recessed, suspended. So that's what we did. We placed them in the model. After you place them in the model, Karen, you have to establish calculation zone. The calculation zone, guys, remember the hallways we said put your calculation zone as 0, everywhere else is 2.5. I can't emphasize math. You guys are going to be doing the same calculation for me next project. So if you know these steps, I gave you a copy of it. Next time you don't need even Chad's help. Here's what we're going to do, step by step. We're establishing calculation zone, 2.5 everywhere, except on hallways and very limited places. We put the height of the calculation zone as 0. Then, Karen, the last step you're going to do is hit run calculation. Run the software, and you will get the foot candle for every single spot on a 12 by 12 grid, in a 12 inches by 12 inches grid, guys, or 2 by 2, 2 feet by 2 feet, I believe, by default. Everywhere inside. I think 10 by 10 is outside, or maybe 5 by 5 feet, depending where do you need the calculation. You can change it. You want to make a calculation on a grid of 2 feet by 2 feet, or you want to make it a grid of 4 feet by 4 feet. Typically 2 by 2, I believe, indoor, outdoor 5, or 10 by 10. Okay, these are the 7 steps, guys, that we did, ladies and gentlemen, to do the lighting calculation with visual, indoor and outdoor. Do you guys agree with that? Now, after you run the calculation, why do we care? Why ran the calculation? Why do you care? Here's the outcome. That's the reason why we do, guys, our outcome. Number 1, maximum, minimum, average foot candle. The most important thing you guys were watching, Matt, you were watching the average, right? You want to meet the average. That was step number 1, meet the average. So based on the recommendation, we met the average. Then, now we met the average, 40, 50, 60, whatever the average is, IES recommended average for this room, we've met it. Now you met the average is step number 1. Step number 2, guys, is you need your maximum to minimum to be as small as practical. That will give you a best distribution. What does that mean, max to minimum? Means that the difference between your brightest spot in the room and your darkest spot in the room is very small. Ideally, we would like the brightest and the darkest to be the same. So basically, everything is the same, average, right? But you can't achieve that one. So you're going to try to make him as close to 1 as you can. Sometimes 2, 3, but as close to 1, the ratio is as you can. Here you go. Then maximum to minimum ratio, that will get you the distribution of your light. Is it good distribution light or bad? If you come up with 100 to 1, guys, maximum to minimum, that's bad. If you came up with 3 to 1, 2 to 1, 1 to 1, that's a good distribution ratio. Maximum to average and minimum to average, these values, guys, will show you how good of a distribution system you have. You want these values to be as close to 1 as you can. So now we got all this information. Then the last thing that we get, Karen, is layout of the luminaires. Now when we check our average is good. Our maximum to minimum is as good as we can, 2 to 1, for example. Max to minimum. We're good with it. It shows you the layout of your fixture. Now I know where physically, mechanically my fixture will be mounted in this room, right? Is that what you guys did? Physically, mechanically. Now I got the layout. Then we didn't do this one, Derek, but the software is capable of doing rendering. It gets you rendering, colored, walkthrough even, AGI. You can make it render color beautiful. You can put your picture there, and so it does a lot of visual stuff that you can take to your customers as you try to convince them why should they hire your firm for $500,000 to design this lighting project for them, right? Don't you think you need convincing tools? If you go and talk to an average Joe about the foot candle, would you think an average Joe will understand that? If you take a beautiful picture of a room, a conference room rendered, based on a direct indirect light, and you put it right in front of this facility manager and say, here's what your room is going to look like. Don't you think you have a better chances of convincing him or her than if you just go and say it's going to be beautiful? Trust me. Do you guys see why rendering is a big deal? The guys who spend their life doing lighting, which you gentlemen, we have IES coming on Tuesday, Derek. I invited them to be here. The IES of North America, their Twin Cities Society. They're coming to talk about, their membership and benefits and what's not. So if you were to spend your life being a lighting designer, rendering is top notch. Wait, okay, here's your rendering. The second thing that you get is luminary schedule. You need to know what type of fixture that a contractor guys want to buy, right? So that will give you a detailed information, catalog information about your fixtures that you can give to the contractor to purchase these fixtures, number one. Number two, Derek, what did we do with it? You guys remember how we used this data to do the what? Energy code. Remember that energy code thing? We used it also to run our energy code calculation on this building, the schedule. Then you put all these guys in something called project documentation. You document that you guys are going to be documenting it, making 22 by 34, printing them, project documentation. That will be required by certain building inspectors. You give it to the inspector, the lighting inspector guy, the building inspector, because if in certain areas there is lighting ordinances that you have to meet, and you can prove to them that the foot candle at the property line is less than 0.25, especially for outside light. For outside light, there's ordinance for lighting pollution. You don't want to pollute the neighborhood with your lights. And indoor, of course, as well as outdoor, there's laws related to the energy conservation, right? Energy code. So between the energy code and the pollution, you have a lot of restrictions on what type of fixtures you need. So you need to document all the stuff that you did, guys, so you can show it to the authority having jurisdiction. Say, I'm no dummy. I have done my homework. Here's what I did for this project. So you can get your approval for your project to move on. Any comments, guys? Any questions? Any comments? Any questions? So that's what we did. That's what chapter 12, guys, talks about, how to do all these steps, step by step. And you guys, no doubt in my mind that you've done it. Chapter 16, the last chapter, guys, lighting and drawing step by step. Take it to the next level. Chapter 16, take it to the next level, Karen. After you finished all this lighting, what did we do? Do you guys remember what we did? After we finished all this lighting and everything is cool and ready to go, we exported to CAD our layout. We imported it from CAD into Revit. Is that what we did, guys? Export to CAD, import to Revit. And when you guys imported it into Revit, what did we do next? You drop the actual physical fixture, 3Ds and intelligent devices into Revit. And what did we do? So you drop them exactly where they should be. And then what did we do? We drop them, then we tag them with the fixture type, the switch that's going to switch them, and the circuit that's going to power them. Right? That's what you guys did. So you circuit them, and you switch them, and you tag them. And that's exactly what the whole chapter 16 talks about. You take all your fixtures after you do the calculation into a drafting software like CAD or Revit. We're doing Revit. We took it to CAD. From CAD went into Revit, imported into Revit. We lay out our fixtures in 3D, guys, into that model. We circuited all these fixtures. We switched all these fixtures, high voltage or low voltage or occupancies or what's not. And we tagged these fixtures with the fixture type, the switch that's going to switch the fixture, and the circuit that's going to power that fixture. And gentlemen, hopefully they'll pay us when we submit our product. Here's your lighting layout and circuiting. They call it lighting layout and circuiting. Any comments, guys? Any questions? Any comments? Any questions about that? Do you see how it meshes together? Everybody can see the picture. We start with verifying the lighting requirement into visual, documenting it for energy code and inspection. We take it into Revit now after we're confident that we meet the code, the energy code, as well as the inspection. We take it to Revit and we start circuiting it. So the next, guys, when you print it to your friend Chad, 22 by 34, that's what you're gonna give to the electricians. The electrician's gonna go fix these, put them in the wall, in the ceiling, suspended ceiling, or hang them, or whatever the fixture is gonna be mounted at. Any comments, guys? Any questions? So that wrap up the whole thing that we did with lighting. Now, redemption. So you guys are going to do the same thing. It's like what we believe, guys, in hitting the same thing at least 2, 3 times. You're going to doing it this time. We went over it. You're going to take the same information next project and do it for a 25,000 square foot industrial building, 2-story building, step by step. So Derek, when we reach May of 2014 next year, right? You're going to be doing the same thing, these steps. So I can't emphasize enough, guys. And if you stay in this industry and you get into the lighting business, that's what you're going to be doing. So get it once, and hopefully it will make you money one day. Right? Any comments, guys? Any questions? Any comments? Any questions? What's important in the chapter is what I went over. So that's basically all what I want to go over. Any comments, guys? Any questions? Cool. Okay. Thank you.